Hey guys, what we're going to talk about today is evaluating expressions with variables. And there went my marker. Luckily I got another one here. So effectively, we're going to be looking at equations like this, like number 1 and 2 I have written up here. A plus a squared minus b, something like that, right? We got a lot of variables, we got some exponents, maybe some coefficients even like we have over here. And we're told what the values of these variables are. Now, if you're looking to evaluate expressions without variables, if you're not quite ready for this yet, I have a separate video on my channel that goes over how to do this with just whole numbers in there using order of operations. This is kind of one step beyond that. So check it out if you're looking for it, but otherwise we're going to get this started. So the really important thing is for us to start making sure we can identify what the variables are equivalent to. Now, as you probably know with variables in math, they can equal anything, right? Especially when we're talking about graphing or something like that. You know, x or a or y or whatever it might be could be 1, it could be 1,000,000, it could be negative 1,000,000, it could be anything in between. But when we're evaluating expressions, we're given one specific value for these variables. So if we look at problem 1 here, this is a problem that just has a and b with it. And we're told, right up here in this box I wrote, that a is equal to 3 and b is equal to negative 2. Now we're also told what x and y equals, but is that important right now? It's not. It may be important in number 2 where we see some x and y variables show up, but right now we just want to focus on the numbers and variables that are impacting the problem in front of us. So that is just going to be 3 for a and negative 2 for b. So what we need to do at this point is substitute those variables or those values for the variables. And to substitute a value, we simply write it where the variable originally was, but we put it in parentheses. Now, some people are going to tell you just put it in parentheses if it's a negative. But personally, to keep things clear for myself and what I found many students like is just putting all the numbers and variables that you substitute in. That way we can keep it clear that these are the numbers we put into the equation for the variables. So anytime I see an a, I'm going to write a 3 in its place because we're saying a and 3 are the same thing, so I may as well write a 3 instead of an a because that's a number that I can work with. I can't do much with a, but I sure as heck can work with 3. So I'm going to keep all of my signs, everything like that, the same. So this plus is still going to be here. And then whenever I run into this a again, I'm going to do the same thing. I'm going to write a 3 in its spot. But what happens to that 2 up there? Does it go away? Does it go inside the parentheses? Does it go outside the parentheses? Well, if you said outside the parentheses, you'd be right. Because we are specifically just replacing the a. Everything else around it stays there, goes on the outside of the parentheses that we're putting our substituted number in for, and will be transferred over to our new equation. So this 2 just transfers right down there because we're just replacing that a. Now finally, we have a b show up, and b says it's equal to negative 2, so I'm going to put that in parentheses as well. Now that I have all my numbers substituted into the equation, I can look to my order of operations to go ahead and finish evaluating this. My order of operations is written right over here. We start with groups, which usually we would be looking for parentheses or brackets, absolute value, something like that. And we do see parentheses here, but as you guys know, there's nothing in these parentheses to solve or to simplify or evaluate, whatever synonym you want to use there. You know, we just have a single number. If there was a little expression inside one of those groups, then we need to do that first. But in this case, we just have parentheses around individual numbers that we substituted in. So that's good. Next up is exponents and radicals. Do we have any of that? Absolutely we do. We have a 3 squared right here. So I'm going to replace that. Well, 3 squared is just 3 times 3, or 9. I'm going to keep these numbers in their parentheses as I'm solving this, just to keep things kind of clear. And finally, we're able to move on to multiplication and division. We don't have any of that though, we just have some addition and subtraction. So we can move on to our final step, working left to right. 3 plus 9 is going to get us 12, and then we have minus negative 2. What's going to happen when we subtract a negative 2 though? Well, subtracting a negative means we're actually adding, right? The 2 signs combine to form a plus sign. So really what we're looking at is 12 plus 2, and we get 14. Hopefully that's not cut off the screen, but we'll find out, I guess. And that finishes up our problem. Now, if you don't want to keep these in parentheses all the way through, it's not something you have to do. It doesn't mathematically impact anything. It just depends on if that's how it works for you to see it clearly. It's what works for me personally. Whenever I combine 2 numbers, I keep those parentheses just to keep it separate of whatever else is there. But if that gets confusing to you, if you prefer not to use those parentheses, it's not something that has to be done. All right, let's take a look at number 2 here. So we have 7x plus 5xy squared. Well, this is where these x and y's come in. We see that x is equal to 4 and y is equal to negative 1. So let's go ahead and substitute. So in place of that x, I'm going to write a 4. Now you'll notice the 7 stays exactly where it was. It goes outside of those parentheses. Instead of multiplying 7 by x, now, whenever we get to that step in the equation, we're going to be multiplying 7 by 4. All right, let's keep substituting here. 5. Again, in place of x, we have 4. And then in place of y, we have negative 1. And that squared is going to be outside those parentheses again. All right, so let's go ahead and evaluate this using our order of operations. Do we have any groups? We don't. There's no expressions inside parentheses here. Do we have any exponents or radicals? That we do. We have a negative 1 squared. Negative 1 squared, what's that? Negative 1 times negative 1? Well, that's going to be positive 1. So this is going to look like 7 times 4 plus 5 times 4 times 1. Let's keep going. Multiplication and division. We have a lot of multiplication going on, so we're going to work left to right to work through any multiplication or division that we come across. We're going to begin by saying 7 times 4. Well, that's going to be 28. And then we still have 5 times 4 times 1 here. We can go ahead and continue to pass on through left to right, finding that multiplication or division, but just multiplication in this case. We have 5 times 4 times 1. You could multiply those individually if you want, or you can multiply all 3 at the same time. I think all of us can do all 3 here. 5 times 4 times 1, we know that is 20. So we end up with 28 plus 20. And then we just get to add those as our final step in our order of operations to make 48. And we finished up with the problem. If you have any questions about evaluating expressions and substituting in values for variables, feel free to drop it below in the comments. I'll get to it if I have the opportunity to. Otherwise, thanks for watching, guys, and I'll see you in the next video.